Hey, good people, how are you? This is Trockers. Thank you so much for tuning in. Okay, we have a problem on differentiation, focusing on, on optimization. We are given those two diagrams. The diagrams above show a cube of side x centimeters in the cuboid of width 3x centimeters, height 3x centimeters, in length y centimeters. The total volume of the two solids is kept constant at 34,000 cubic centimeters as x varies. A, find S the total surface area of the two solids in terms of X only. B, item 1, hence find the value of X for which S is the minimum, justifying your answer. In part B, calculate this minimum value is, calculate this minimum value of S. All right, so without further ado, let's get started. Okay, so I am not good at drawing, but I'll try. Okay, so we are given this cube here of sides x, 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 and we have a cuboid here, right? We are given that. Okay, so this is y, this is 3x, that's 3x, right? And the diagram shows a cube of side that. And we are told that the total volume of the two solids is kept at constant at that. So volume, let's just say volume, we know that volume is 34,000, right? So this information is very important. So total volume, we are going to say x cubed plus 9x squared y is equal to 34,000, right? We need it here. We are going to use it, okay? Then part A, find S the total surface area of the two solids. So to find the total surface area, right? This is part A. Okay, so for part A, right, for total surface area, as you can see here, we've got 6 faces, so it's going to be 6 times side by side, plus here, you see, these are 2 faces, so it's going to be 2 times 9x squared plus, so this, if you come back here, right, you see the 3x times y here, it's 1, 2, then at the bottom again is 3x times y, so there are 4 of them. That plus 4 times 3xy, right? This is our total surface area. Okay, now let me roll up. So S is going to be 6x squared plus 18x squared plus 12xy, right? So S is equals to 24x squared plus 12x. But remember, they say in terms of x only. So I'm going to make y the subject here. So to make y the subject, it's going to be y is going to be 34,000 minus x cubed over 9x squared. So I'm going to replace with 34,000 minus x cubed over 9x squared. So let me try and simplify this. So if I try and simplify this, I'm going to get 24x squared, right? So here, what is, okay, 12 divided, okay, let me just say 3 here, it's 4, 3 here, that's 3, right? So what is 34,000 times 4? It's, it's going to be plus 136,000x over 9 over 3, not 9, but over 3x squared minus, right, 4x to the 4th over 3x squared, right? And here it simplifies to 24x squared, right, plus 136,000 over 3x right? Minus 4 over 3x squared, right? Okay, so we can still combine that and that. So 24 minus 4 over 3. So I'm getting S is equal to 68 over 3x squared plus 136,000 over 3x, right? So this is the total volume, right? This is the total volume in terms of x only. Let me see if I did the correct thing here. I substituted this by that, right? Then from there, when I plug that in, right, that was 34 x, yeah, x and x cancel out, remains x there. Then this was x and x cubed, x to the fourth divided by x squared. Yeah, that's good. All right, so let me see, substitution here. Yeah, that's it. All right, so I believe we did the correct thing. Then part B item 1, so B item 1, it's asking us to find the value of x for which s is a minimum, and we need to justify our answer. So we know that when s is a minimum, okay, just like s is 68 over 3x squared plus 136,000 over 3, right, x to the negative 1, right, x to the negative 1. So now when we differentiate, if to find the optimum value here, ds dx should be equal to 0. So this implies that 68 times 2, so it's 130, 68 times 2, 136 over 3x, then minus 136,000, right, over 3x to the negative 2, which is just x squared, equal to 0. So this is what I'm going to do. All right, so it's going to be 136,000, right, over 3x squared is equal to 136x over 3. So the 3 here will cancel out, right? So it's going to be 136, okay? Sorry. So it's going to be 130, sorry. It's going to be 136,000 over 136, right? Which is equal to x cubed, right? So 1,000 or 1,000 here is equal to x cubed. So cube root of 1,000 is equal to x. So therefore, x is equal to 10. But we need to justify that this is a minimum. So when this is a minimum, it means the second derivative here, it was s, right, must be greater than 0. So let's go back to where we have differentiated there. So let's see. So if we say d squared y dx squared, we are going to get what? 136 over 3, right? And remember this one here was, okay, it's 136 over 3x minus 136,000, right, over 3x to the negative 2. So when we bring this down, it's going to be what? 272,000 over 3, right? Then this is x to the, okay, to the negative third, which is just x cubed there, right? So when we substitute x equal to 10, it's 136 over 3 plus 272,000 times 10 cubed is 1,000, and this over 3,000, which is all we want is just to show that this is positive. So 136 plus 272, which is 408 over 3, which is greater than 0. So we have proven that this is a what? That's a minimum. So now we need to calculate that value of s, where it's what? It's minimum. So we are supposed to go back here, right? We need to go back here, then we just write down. So for b item 2, you just have to calculate 68 over 3 times 10 squared plus 136,000 over 3 times 10. That's our s. So s is equal to 68 over 100, 68 times 100 over 3, right, plus 136,000 over 30, right? I'm getting 6,800 this way. So this is 3,800 square centimeters. So this is the minimum value of the surface area. So guys, this is how we play around with this. I hope you enjoyed the video. Let's continue to watch more videos and let's continue to do more practice. With that being said, I'm signing out. Take care and thank you so much.